Good morning, all. I am Professor Prashant Mahajan. So, today we are going to see the new topic spectroscopic techniques. So, first of all, we are going to see the introduction about the spectroscopy. So, what is spectroscopy? So, spectroscopy is the branch of science that deals with the interaction of the radiation with the matter. That means that electromagnetic radiations which can be obtained from the source, that is like deuterium lamp or tungsten filament lamp, that reacts with the matter, and depending upon the wavelength that is produced by the source, the radiations are going to react with the matter, and the changes are going to occur in the molecule. So second thing, spectroscopic methods of analysis are based on the measurement of the electromagnetic radiation emitted or absorbed by the sample. So when we are going to apply electromagnetic radiation on the matter, that radiations are going to absorb, then the molecules are going to the excited state. When it comes back to the ground state, it is going to be emit light, and the color of that light is depend on the wavelength of absorption. Next, therefore the physical and chemical properties of the substance is directly related with the structure of that molecule. Electromagnetic radiations consist of a discrete packets of energy which is called photon, and that energy of photon is given by E is equal to hc by lambda. So E is energy of the photon, h is the Planck's constant, c is the velocity of the radiation, and lambda is the wavelength. So EMR travel at a speed of 3 into 10 raised to 8 meter per second. The speed of the wave is given by velocity is equal to wavelength into frequency. That means electromagnetic radiations are characterized by wavelength and frequency. So electrical and magnetic component oscillating at right angle to each other and at right angle to the direction of propagation of waves. That means if you want to understand this concept, you please see the corner of the room, that one line is electrical component, second line is magnetic component, and third line is propagation of the wave, that is direction of propagation of wave. So they possess both properties of wave and particles. So this is I am talking about, that one is I'm talking about the corner of your room, that is one is electrical component, second is magnetic component, and third is the direction of propagation of wave. So what happens when electromagnetic radiation reacts with the matter? So you can see the diagram first. So this is the total electromagnetic spectrum. So if the wavelength is 0.07 picometer, or the rays are cosmic rays. If the wavelength is in between 0.07 picometer to 0.6 picometer, it is gamma rays. Then next is X-rays, vacuum UV, UV, visible, near IR, IR, far IR, microwave, and radio waves. So this is the total electromagnetic spectrum. When cosmic rays and gamma rays falls on the matter, it is going to excite nucleus. Sorry. When X-rays are going to fall on that matter, core electron excitation is going to be takes place. When UV visible light falls on the matter, electronic excitations occurs, and when IR radiation falls on the molecule, there will be bending vibration and stretching vibration going to be occur. When microwave region radiation falls on the matter, there will be molecular rotation, and in case of radio wave, there will be electron spin resonance and nuclear magnetic resonance. So in this chapter we are going to deal with only UV visible spectroscopy and IR spectroscopy. So you can see UV visible region range is 200 to 780 nanometers. In that region, excitation of electrons are going to be takes place. That is from bonding orbital to the anti-bonding orbital. Absorption of IR range is from 2.5 to 50 microns can cause vibrations in the certain covalent bond. So vibration includes stretching vibration as well as bending vibrations. So microwave cause rotation, radio wave cause nuclear magnetic resonance. So you can see E is inversely proportional to the wavelength or lambda. That means from this direction that lambda is increasing, that means energy is going to decrease. So you can see delta E rotational is less than delta E vibrational is less than delta E electronics. Means this is delta E rotational, this is delta E vibrational, this is delta E electronic excitation. So energy is inversely proportional to the lambda max. Next, this UV visible spectroscopy and IR spectroscopy is based on the two laws named Lambert's law and Beer's law. So what is Lambert's law? So Lambert's law states that when a monochromatic radiation is passed through a solution, the decrease in the intensity of incident radiation or light with thickness of the solution is directly proportional to the intensity of incident radiation. So you can see this diagram, that is I0 is the intensity of incident radiation, then IT is the intensity of transmitted radiation, that C is the concentration of the solution, and X is the thickness or path length of the solution. So the mathematical formula for the statement is minus di upon I0 is directly proportional to dx. So after integrating, you will get minus di upon I0 is directly proportional to dx. So finally you will get that is IT is equal to I0 into e raised to minus k1x. That is the derivation for Lambert's law. Then second law is Beer's law. It states that when a monochromatic radiation is passed through a solution, the decrease in the intensity of incident radiation with concentration of the medium is directly proportional to the intensity of incident radiation. That means minus di upon I0 is directly proportional to dc. After integrating, you will get the formula IT is equal to I0 into e raised to minus k2c. So Beer's law is depend on the concentration of the solution. That means as the concentration increases, the intensity of incident radiation decreases. In the case of Lambert's law, it is depend on the thickness of the solution or path length of the solution. That means as the path length increases, the intensity of incident radiation is going to be decreased. The next is combined Beer's Lambert's law. So it tells that a decrease in the intensity of incident radiation is directly proportional to the thickness and path length of the solution. So after integration, we will get IT is equal to I0 into e raised to k into x into c. So that log of I0 upon IT is nothing but the absorbance. So finally, absorbance is equal to A is equal to log of I0 upon IT is equal to K into X into C. where A is absorbance, I0 is the intensity of incident radiation, IT is the intensity of transmitted radiation, K is the constant, X is the thickness of the solution, C is the concentration of the solution. So depending upon the concentration unit, we are going to change that K. So if the concentration of the solution is in the gram per liter, then that K is called as absorptivity, and if the concentration is expressed in moles per liter, then it is called as epsilon, that is molar absorptivity or molar extinction coefficient. Simply we are going to relate that Beer's and Lambert's law to the colored cloth. That means in winter season generally what we are wearing, we are wearing colored clothes. That means that colored clothes are absorbing heat and keeping our body warm. So that is nothing but related to the Beer's law. So more the color, more will be the concentration, more will be the absorbance. So that is called as Beer's law. Second thing, we are wearing uh, dark color clothes, and second is we are wearing thick thick clothes, that is like sweater. So that is related to the Lambert's law. So thickness is directly proportional to the absorbance. But generally we are dealing with only concentration. As you can see, the size of this cuvette is going to be constant. So we are going to keep that thickness constant and we are going to vary that concentration. So that is called as combined Beer's-Lambert's law. So next term is transmittance. So you can see absorbance is directly proportional to minus log of t. That means A is equal to log of 1 upon t. So as absorbance is going to increase, transmittance of the solution is going to decrease. That means if we get absorbance and concentration graph with positive slope, then we are going to get the graph of percentage transmittance versus concentration with negative slope. When your graph is crossing through origin, then you can say that Beer-Lambert's law is verified. Thank you.